So, good evening, everyone. We will we will start from where we ended the last day. Okay. So, we just go to some concepts, uh, some some philosophy, and then from there we will get to the subject. Okay. So, when I tell we will go to some philosophy, what that means is, see, we saw like people during various parts of the history thinking about the universe, thinking how it is functioning. And many people having different philosophies of how we should approach this problem of understanding universe. So the first question for that was, it are we human beings supposed to inquire that? Are we expected to look at what is there in this universe? Or is it a sin? Or is it a crime? Shouldn't we be subservient and just live? So these were the kind of philosophical issues people had much earlier. So that is one of the biggest contribution of philosophers throughout. They felt, we have to. And then what happened is, like even Saint Augustine, like one of the famous Catholic preacher, Saint Augustine. So he also gave an explanation within the tenets of the Catholic Church that yes, well, God has made everything, but human beings can inquire. There's nothing wrong in inquiring how these all things are done. And in different philosophies, people had, some kind of an inquiry. So that is where we talked about Plato, Aristotle, and all those further developments which happened. Now you see, when it came to Aristotle's time, till that time, like Aristotle reached to a point where he started telling we have to observe what is happening in the universe and then learn how things are going. There is no other way, there are no other shortcuts for you to know what is happening, kind of stuff. And then from there we go to know, when it reached this guy, when it reached this guy called Kepler. See, what happens is that if we really look at how what is the relationship between nature and what we call as science. So if we think like this is nature, like natural phenomenon, okay, and within nature we know, there can be many compartments. There is water, there is air, there is sky, there is soil, there are many things, what is happening in nature. So this humble human who was always trying to look at these things at nature and trying to figure out what is going on, how it is functioning, because it starts impacting his life in different ways. So, what during the initial days, what people call as science, was this person's understanding about how this nature functions. Understand? So, like if we tell this is the nature or universe or whatever we call, so one definition of science is like we are trying to understand how this natural phenomenon are function, how those things are happening. Which means when we use the word called invent, that is already there. Okay, so even people differentiate between two words, discover and invent. So we tell Columbus discovered US America, okay, or Madame Curie invented so and so kind of periodic table element, or CV Raman invented Raman effect. So what it means is actually both are there. If you see philosophically, both were there. Only thing we are going and trying and finding out chaya isatha. So most of the science is something like it is already there. There is some way tsunami is happening. Now so one scientist is finding out this is how tsunami is happening. But it is already happening. So you are only trying to understand how things are. functioning in the universe. But then, of late, bit more, and in the initial period also, people started understanding universe and along with that, modifying the universe also. So that is another realm of science. Like you try to modify, you create a new element, you create electricity from waterfall, or you create a new gene, and you develop a new species of mango. No, you are budding and create. So that is like you are creating something new, of course, using the existing matter in the universe. Like as we had told before, there are only two things: matter and force. So using the existing matter and force, you try to create something new. And then there are a lot of philosophical questions. So are we supposed to create something new? Is it not something very well planned and divine? Well, it is having both sides. One, yes, when something gets developed in nature, I mean, things don't get developed by thinking that, oh, I'm creating something or something is happening in nature, so this should be good for human beings and this should work. That is not the case. So there is one very famous US scientist who tells, somebody tells, no, your person, human beings are made so carefully. Everything functions so perfectly. You have eye to see, and then you have nose. So is it not a perfect design? So he says by telling that, most, if it is a perfect design, why should I eat and talk with the same mouth? If I have my feeding of the mouth was on back end, if I were talking, I could have eaten from here. So it is not so perfect a design as what you think. Like if it is so perfect a design, why should I get so old, and or why should people die because of certain diseases? So it is not that kind of like an intelligent design what Arun was mentioning other day. It is because of so many other parameters, and in that aspect itself, why there is life on this tiny part called Earth itself is a big question. Why there is life? Okay, so there are many theories for that. Is it accidental or incidental, or it is planned, or it is intelligent, this kind of stuff. Now, long and short of the story is, in science, normally we classify things into two things. One is discovering or inventing the already existing universe, which is there, or nature. And second is you are trying to now develop something new using the existing elements. Now, when you do all those things, how will you express it? How can you express? So we want, like, people have different languages. People have sign language. People have written language. So now each person will have their own way of talking things. So how do we bring everything into a universal way? Not like writing down how science functions, what happens, but the essence of it. That is what we call as abstraction. The essence of something. So Sujit was telling me, like, you draw something about a phenomenon, you can't remove anything from that. So that is the best abstraction. Okay. So which is very similar. Like you represent something, and you represent something that is the essence of it. Nothing less and nothing more. Okay, so that is what we call, that language is what we call as maths. So maths is the language of science which is used to abstract the natural phenomena, so that we keep that as a universal language. A person from Japan, India, US, everyone can read it in the same way, same function, and nothing is there to take out from that. That is the epitome. Okay, you get that. So you try to understand nature through science, and science tries to express through a language, and that language is maths, and that whatever you tell as mathematical equation is the abstraction. It's also called abstraction. Mathematical equations are also called abstraction. It is called abstract science. It is the abstraction of a natural phenomenon. But then the trick is, like Vani was telling other day, sometimes the certain maths will directly correlate with the nature. Of course, it is abstraction. Of course, it is representing a natural phenomena. But certain mathematical stuff will will have a direct impact on the nature, directly represent. So this is what Plato was telling. So Plato's thing was that purely with mathematical geometrical pattern, you can define nature. The entire nature as a mathematical point. So that series of Fibonacci series and whatever she was mentioning, there are a lot of stories by telling that if you draw, many artists try to maintain that ratio. So Fibonacci series tells about a ratio which they call as a perfect ratio. So perfect ratio which is aesthetically pleasing. So even some of the Dali's works and all actually have many of the artists try to they have a lot of myths, I don't know, or maybe it is true that they try to maintain that ratio in some of the works. Even in that Mona Lisa and all those things, people have tried to decipher that using that concept of how it is direct maths kind of stuff. Okay, so now this is the crux of the positioning between science, maths, and nature. So this I hope like you get it. So whatever we are telling is all within this, inside this. Are we game?
It is also like you don't need to follow it, but this golden ratio or this Fibonacci series of number, we tend to associate or we tend to like those works, those designs which are in compliance with these numbers or golden ratio. Like there is this very famous architect. He passed away 2 years back. I.M. Pai. He designed a pyramid in front of Louvre Museum, and he simply asked his assistants to design, make several models, and he picked one. And then when they measured it, it was according to the golden ratio. Or like the pyramid of Giza is also according to the golden ratio. But they never intend to, they never calculated it to be so. So we simply like those designs, those structures which are in compliance with these numbers. It, sort of we are wired to this design or whatever.
Yeah.
Involuntarily used. No need to plan. That's what they say.
It is also the case of this DNA structure, no? Like I've read somewhere this PM Bhargava, the scientist who written about that, there were many other versions of DNA structure, but this structure has a aesthetics, so they suddenly fall into it. So the structure made it in a way that like some sort of a aesthetically very well ratio or thing, like so maybe that is also one thing. Maybe yeah.
Okay, okay. Only one thing is, when such things come, people normally try to freak out using this.
Mhm.
Then they will try to bring a lot of things which are not there also. Sometimes, when things like this comes, they will try to figure out some texts from past and try to tell that, oh, they designed this as per this and all those things. So that myth issue is
Yeah.
always there. Yeah. But otherwise, I don't know. The pleasing part of aesthetic part is quite subjective. But this is true that
Mhm.
even many of the petals of
Mm.
flowers that follow that
Mm.
pattern.
Yeah, but sometimes we can't express why we like something, which is I believe that is because of this.
Yeah, could
This is
be.
also one reason. Yeah, this is also
Yeah,
one reason. Yeah,
could be one of the
yeah,
reasons. Yeah.
yeah. Because when you see this Apple, the success story of Apple laptop, he actually a calligraphy trained guy, no? So his calligraphy is the one thing which hit first, then the other
Okay.
things come in the. Yeah, that's what I've heard. Even in his talk he's mentioning that, the typography, which he used in the keyboard, which is very special,
Yeah.
so yeah.
Oh, okay. Yeah. Could be there.
Yeah,
Yes.
so the design is not sometimes like effect directly, but indirectly or subconsciously it has a greater effect, which I That I
Okay.
feel
Yeah.
in painting especially. Yeah. Yeah.
Great. Okay. So now, why I specifically mentioned that we will get into this is because normally what happens is some scientists and some researchers will try to understand nature, and in the process they will develop the abstraction for it and maths for it and represent it. Okay. But what we learned in the last class actually worked in the reverse of it. The reverse of it is that like somebody called Kepler, he understood the maths of this first, but he didn't understand the science. So now that is why I thought I will get back to that again. So this, they understood the maths of it, that it is elliptical. It is elliptical. All the orbits are elliptical. Then he understood the next maths by telling that the area of all the triangles, if you draw it like this, will be the same. And then he did this next one, which I told. Actually, I have shown it like this, but the actual Kepler law is this. He got the maths first. What was the maths? Maths is like if you have anything which is rotating, how much time something takes to rotate is called period. Normally in science, we call period, means we tell the class 1 period is 1 hour, like that. It is normally the time for completing one cycle. So in rotational motion, the time for completing one rotation is period. So Earth in its own axis 24 hours takes for one rotation, one revolution is 365 days. It is period. So now that is the period, and there is this distance, the distance from the center, which is sun here, to every planet. So this guy, Kepler, identified there is an important relationship between these two. The distance between a planet, which is actually the radius of this orbit. Radius of the orbit means from the center to any point in that path, which is actually the distance between sun and that planet. You understand? The distance between sun and earth is also the radius of the earth orbit, right? Yeah, because sun is the center, earth is rotating. So distance between sun and earth is the center. Is the distance between the center of the sun and earth is the distance, is the radius of that earth orbit, right? So that two things, the radius of the orbit and the period, that the time for revolution. Obviously, when the radius is increasing, the time taken will be more, right? When the radius increases, you are farther, so you have to travel more distance. Like when you are farther, like Jupiter will have a more radius than Earth, so Jupiter will take more time. So that is obvious, understood. But is it proportional? Like if radius becomes double, does the time taken double? When the radius is triple, is the time taken triple? So Kepler figured out no. The relationship between these two, that is the period, the time taken, Earth takes 1 hour. Okay, if Earth takes 1 year, if Earth takes 1 year, Mercury takes only quarter an year, Saturn takes 30 years to complete one revolution, Pluto takes 250 years. Okay, so this is the time taken, and you see this is the average distance from the sun. So if you take distance from Earth to sun as 1, that is a unit called astronomical unit, just to simplify the things. For Earth, everything you take it as 1. So if you take it as 1, here you take Earth, here is 1, right? So this distance, if you take it as 1, then Pluto is 40 times of that. But you see, period is not 40 years. This 250 years. Okay, so that is the, then he told him what is the relationship. There is some relationship. Of course, the time is increasing. What is the relationship? So he came up with this relationship. That is his brilliance. He observed the mathematics. T squared by r cubed is a constant. Square of period divided by cube of the radius is a constant. 1, 1, 1, 1, 1. So this is massive. Actually, what does it mean? So it means that the farther you are from the sun, you go slow. That is it. That is its meaning. So the farther you are, your speed reduces. That is why you are taking more time. If your speed is same, if the distance is 40 times, the time taken would have been 40 times. But speed is reducing. That is the meaning of it. But see the method, how he got about it, he identified this relationship, that maths he first observed, which people had this data before also, but this is a tough thing to observe. This is the relationship. So he didn't get the science of it, he got the math of it. Now, Newton comes later, from the maths, he developed the science. Why is d squared by r cube is possible? Why is it ellipse? Like I sent that derivation, that is Newton's derivation. To Arun, I sent the other day. That is Newton's derivation. So he told why it can only be ellipse. Otherwise, why it won't be stable. Okay. So like Martha sir told the other day, he told that this is gravity is what is causing all this. And he came up with an equation for gravity. Okay. So he told there are only two things important in gravity. Every mass has gravity. That is his disposition. Every mass, anything with a mass is having gravity. So projectile is having some gravity. Iron is having some gravity. So iron will attract the canvas which is sitting behind him. And the canvas sitting behind him will attract iron also. Okay. But your gravity is a very small force, very tiny force. So you need like so much of mass to have some impact. So only like big planets or big meteors or big mass has gravity. So he told only two things are important. One is what is your mass? What is the mass of all these objects? If you have more mass, you will have more gravity. So gravity is directly proportional to mass. That is his theory. Second thing was that he told the farther you are, the distance between two things, it is like a magnet. So two magnets, if you keep it closer, it will attract. So gravity is always attractive. It's like magnets. And if your distance is more, you see, if you keep two magnets at the heavy distance, the attraction will come down. So the second point was, if the distance is more, gravity will come down. So this was the thing which he told, and he gave an equation for that. Okay, that was his point. But that pointed to another massive stuff. So this brought the question, how is Earth moving? So that was in the first place why people like Aristotle had postulated that Earth is not moving because you need a force to move the things. That was their theory. So now the question came like, then how is Earth moving? Who is pushing Earth? What is the theory behind that? So that is where Galileo came with a concept that of something called inertia. He told like you are in your bed early morning, so you get an alarm burst by telling you have to get up, or you feel like I want to sleep for 10 more minutes. So that is the normal inertia people associate. Like you want to be in that stage, whichever you are. Okay, but people think it is a state of rest. It is not necessarily. So your kids, four of your friends and kids are playing video game, or they are playing football and cricket. You go and tell, stop, come and sleep. Actually, you are inviting them to sleep, to rest, but they don't like it. You see, they want to play. So they want to continue to be in the same state which they are interested in. So next day when you're sleeping, you come on to Chala, they have come for playing, you come. They don't want to go. Yesterday they want to play and not sleep. Today they want to sleep and not play. So so the inertia is your affinity to continue to be in your state where you are. So the misconception people had was that it is a affinity to continue if you are resting. So which means if you are moving, you will continue to move. Okay, but people think about Earth. If a cycle is moving, why is it not continue to move? It will continue to move if there is no friction. If there is no friction, if in space, if we just throw something, it will continue to move. So that is the concept of inertia, that when something is moving, it will continue to move, which means Earth was some object which was moving. See, the concept of moving itself is very difficult. Moving compared to whom? If moving is compared to whom? You are going in a train, the guy sitting next to you is also moving. For a person who is standing outside, the guy sitting in the train is moving. But for you sitting next to him, he is not moving. Okay, so movement or motion itself is relative. So that is what Galileo established by telling there is something called relativity. So if anything, you can't tell something is moving, something is going at this speed and all. You should tell where are you sitting and watching it from. Okay, so if you're going in a merry-go-round and 6 of the kids are going in a merry-go-round, your position compared to the person sitting in your opposite is permanently fixed and static. So compared to you, that person is not moving. But when you stand outside, you know that person is moving. And when you are going in a car, that person is moving in a different direction. So depending on your position in the space where you are and what is your motion speed, the other person motion can vary. So that is the concept of called relativity of Galileo. Okay, that's another relativity of Galileo. So this is the concept. So the earth was something which was moving. Moving means compared to maybe sun. So when we tell about everything in solar system, we talk about sun. So compared to sun, this guy was moving. So now sun is having gravity. So sun attracts it. Come. Okay. But then this guy's tendency is to move. Always the object wants to move. So whenever this guy tries to move, the sun's force to attracting it is there. It is just like if you have a ball, like hammer throw you have seen, like hammer throw. The people tell this, do this hammer throw, right? They rotate it like this. So this hammer, if the moment you leave
Yes.
the hammer, the moment you leave the hammer, it will go. Okay. So why that hammer is going like this? So your hand is exerting a force to hold it. So your hand is the connection. So you are powerful. You are more powerful. So your hand is holding it. So there is a force to the center. Center is you. Okay. But at the same time, you have created another motion of the hammer. Hammer is moving, but the hammer's tendency is like when you move it like this, hammer wants to go straight. Because of your hand, it is in the circular motion. So if you have a ball which is tied to a string like this, and if you rotate, same thing happens. Now, if you have something like this, and if you have something like this, and if you rotate, same thing will happen because this string is holding it to your hand. So that force is holding it in this circular position. When that force goes, this if you hold something and you leave your hand, this will go in the straight direction and fall. Is it not? If you are going in a giant wheel, if you open this one, what will happen? You won't fall straight down. You will fall from that whichever position you are there, from there radially you will fall. Right? So that is a motion. Like for example, if you see morning when you get up in your bedroom, where will that yesterday's all the ball wheel garka hoga? If you get up in the bedroom with full fan swinging at night, when you get up, where do you see that your hair, that formation of hairs?
I won't see, but in the
Sorry, I don't- sorry, it was not intended, sorry.
in the corner.
That is to him actually.
No, I didn't mean it. I don't mean it. Unfortunately, wrong example. Okay. You see it in the corner, right? Right. Okay. So, so that is because that fan is in that rotating motion. So from the rotating motion, like if you see this is the rotating motion, the tendency is at any point of time it is to move straight. you know. So what happens is, so there are actually two forces in play here. So whenever you like go, as I told, in a merry-go-round, if you're jumping in a merry-go-round, if you fall, you will fall like this. You will fall, you won't fall here, you won't fall here, you will fall like this. Pradeep, I can't stop laughing. Okay. So you will fall like this. Your tendency to will be to fall like this. That is because you have here, actually there are two forces under play. One force, assume this is earth, this is sun. So now we told between earth and sun there is this gravitational force. Sun is attracting earth, earth is attracting sun, but sun is much more heavier than earth, much more heavier than 99.8% of the mass of the solar system is sun. So remaining, everybody is remaining 0.2, 0.3%. So obviously earth will get attracted. But then earth has a tendency to go straight because that is its original motion. Unless somebody stops it, it wants to go straight. So at every point of, so what will happen? This, because of this tendency to go straight, and sun is attracting like this, what will happen? Earth will move like this. So now this is the new position of earth. At that position also there is a gravitational attraction here. But then again earth wants to go straight like this. This continues. Now the moment, let us assume sun loses its mass, maybe half of its mass. So this gravitational force will reduce, earth will slip away. Earth won't stay here. Or let us assume the distance between a sun and earth drastically increases. Sorry, or drastically reduces. If drastically reduces, earth will go and get amassed with the sun. So that is called equilibrium or balance. So that happens in that balance. You get that? So that is the reason for this Earth's orbit. So the important finding was that two findings. One, Earth got some movement originally. While it formed itself, it was just moving compared to sun. So while it was going close to sun, because of sun's gravitational force, it came and this path was formed. So that happens in many other parts of the universe also. So this is the explanation. Does that make sense? Okay. So this was massive, which could explain lots of stuff. So then, actually, if you see, we see gravity in every day also. Like, I hope you know that the waves are happening because of moon. Okay, waves are happening because of moon, because of the attraction, the gravitational attraction of moon and earth is where this wave means high tide and low tide. So this high tide happens. Okay, but then if that was the only reason, tide should have happened only once in a day. But tide happens 2 times a day. See, tide happens 2 times a day. So that is tricky. So what happened is, it is very, very tricky, very interesting also. You see, when because of the portion which is closer to moon, the portion which is closer to moon in the earth, it gets a pull. It won't be this much of a pull, a slight pull. But then water is not very strictly, rigidly held on to earth. It's liquid. So the mountain will not come like this. So the mountain is more solidly fixed with earth. Water is not that solidly fixed, right? Water can move a bit more easily. So then, because of that, you see that water slightly peps up. That because of that gravitational attraction. So there is a tilt. The whole water body there is a tilt. But then what happens? The water which is on this side, that has least of gravitational attraction with moon because it's on opposite side. And he doesn't want to move. So he stays there. because of inertia. See, the inertia is there. It is like you are holding on to a bus, you are jumping into a bus, and then if you don't hold, you will fall. Or when you when you are aboard or alight from a train, your body wants to move in the same direction. So similarly, this position always everybody wants to maintain their position. So in this side, it is not having this gravitational attraction. So when this water goes in this side because of the heavy mass, it wants to stay put. So it has a bulge here also on the opposite side. So every day this position will come after 24 hour only, but this position will get repeated. So every day that is what we call as like high and low tides of it. One due to inertia, one due to gravity. You see, so people think inertia is like laziness kind of. So people many times tell, yeah, that guy didn't do any job and I was the smartest student. I also became so much, he also became kind of, one person was having some gravity force, applied everything and got some tide. One person just stood in the place where they were, he also got the same effect internally. Right? So it's all very tricky kind of things, how this can happen. You understand this? Okay. Right. So now, do you know why that lady doesn't fall?
Balance.
Yeah. Yeah, okay. What, that is right, but what does it mean?
No. I mean the equal balance of gravity, gravitational.
Correct. Correct. But gravitational force is actually towards Earth. Okay.
Yeah.
Yeah. Equal balance on both sides. So Prajakta is asking what is called inertia. So inertia is what we call this phenomenon that you want to be in the state where you are. The resistance to change. So you want to be in your state, whether you are moving or stopping, walking, you want to be in that state. Right? That is what is called inertia. Right? So there is like, that is the reason for good mileage of motorbikes and cars and all in that 50, 60 kilometer range. It's actually because of that. From this small speeds like 10 kilometer, 15 kilometer and all, like, like when you're trying to move, you have issue to overcome inertia. You have issue to overcome inertia. At high speeds also you have certain other kinds of issues because of that speed. So there is always some optimal speed where you are like you strike that balance. So that is why you see normally cars, bikes, and all, they will tell there is a speed range which gives you optimal kind of mileage because you have to give only less force to move. You overcome inertia also, you haven't gone that very high also. So now Sujit is 50% right that this lady follows some balance. So you can see, balance with respect to what you see. She's balancing with respect to what? You look at it. Balance is right. Balancing with respect to what? Which point? You see, she balances with respect to this point.
Center of gravity.
Yeah. So that point, as Arun told, is like we know, like Earth and any other body will attract. Earth is having a heavy mass, but through which point that attraction will come? So it is not like every point is having equal distinct force. So the attraction will come actually from the point which is the center of mass. So your body, depending on the position of the body, the structure of the body, whether you or a stone or a table, everything will have a place which is the center of that mass. If your body is having uniform density, it will be very easy to find out, which may not be the case. So density may not be uniform. So you will have the center of the mass. So for example, like if we tell I have a stone, Okay, if I tell I have a stone like this, okay. So normally the center probably like, let us assume Earth. If we assume Earth is like really a flat surface, so let us consider Earth as very flat, like this one. So normally, if you take the center is here, a specific point, then from that center to Earth will be where gravity will function. Gravity will get applied. But then, if this shape of this one is complicated, then you have an exercise to find out where exactly that center of mass will flow. It will get further complicated. Let us assume this side is steel and this side is wood. Then the gravity, center of gravity could be here also. This side is steel, this side is wood. Center of the mass could be here also. Because it is depending on where mass is focused. You understand? So for human beings, it's normally in our hip and this area. But well, depending on the structure of different people, like it can vary. So normally for a person here, so she has intelligently pointed out when you have support in your center of gravity is when you can hold something. Okay, so you take your pen next to you and try to hold like this. You can't hold, is it not? You take a pen like this and try to hold. You can't hold, is it not? It is difficult. Okay, or even with a plain hand, it is difficult. But when you have a mass like this, you can hold, right? But when you have a pen like this, you can't hold. Is it not? So that is because when you have a pen like this, the center of gravity will be somewhere in the center, but when it can't balance, it will tilt. It will tilt. So when it tilts, what happens? Center of gravity will not have support. So when center of gravity will have support, then only something can be stable. Right? So this lady is she's arranging in such a way that her center of gravity is having a support. Okay, but then that alone is not sufficient. So that is where the balance, what Sujit told, comes into picture. So look at this picture. Okay. So now if you look at this picture, assuming this is center of gravity, so if you tilt this dabba, so this dabba has come like this. But then what happens when you remove your hands, it will fall back, right? You push this dabba like this, and if you remove it, it will come back. Because its center of gravity is here, it wants to have stability, it will come back, right? And if you push further, till this point, where center of gravity has support, it will stay. But from this position, if you tilt a bit more, when the center of gravity does not have support, it will fall. So anything is falling because at the point when its center of gravity does not have support, it will fall. So when you hold like this, magicians and all, when they hold things like this, they are ensuring that this doesn't tilt. So when it doesn't tilt, what happens? Center of gravity has support in your hand. Understand? Right? That is why this famous toys you would have seen, nah? This kind of toys. Have you seen these toys? This kind of toys? So when you tilt it and keep it, will come back. Yeah. You know how it comes back is it is in a way that this bottom part is very heavy, very, very, very heavy. So the center of gravity will be in a point. So these points will be like vacuum, won't have much mass. So when this tilts, actually, whenever you tilt, center of gravity is here only. So it will come back. Like here. So for example, in this, if you fill this bottom portion with like heavy stone kind of stuff, then the center of gravity will come down. Now that is why when you make a structure like this, bottom when you have it plain, flat, and top if you have it straight also, it will sit. For example, this pen, if I have a structure like this, it will sit. because the mass has come down, so center of gravity comes down, right? Right? Okay.
Yeah.
Okay, so now you look at this girl. Why does she hold that bar? The scene always they will hold a bar, you see. So her trick is to ensure that her center of gravity is straight. And center of gravity of the sports are also in the straight line. Okay, but if it slightly tilts also won't matter, only port will fall down. Because the port's weight is not very heavy compared to her, only port will fall down. But her show, she doesn't want the port to fall down. But then they will always hold something like this. You know why? So that is because of another part, another phenomenon. The thing is, like you would see, let us assume you are rotating. You are just moving. You are just rotating like this, in a dance or something. Let us assume you are rotating like this. Okay. So in a dance, if you are rotating like this, in a ballet dance, if you hold your hands like this, your speed will increase. Okay, if you hold your hands like this, your speed will increase. You would have seen divers when they dive. Dive means like swimming, that competition diving is that when they dive, you see they will hold their hands and legs in such a position that their whole geographical spread is very less. That is because whenever something rotates, the inertia for that, all the inertia, whatever we told, is actually directly based on your mass. So a cycle has less inertia compared to a lorry. So your mass is less, means less inertia. So it is easy to move a cycle. Okay. So, but here when something is rotating, it is not only mass what matters. How the mass is positioned in the geography, terrain where you are, is also important. So your mass spread means your inertia is small. Okay. So what will happen? The person who is jumping, diving, he wants to have more rotation. So he doesn't want his body to be spread like this. So when your body is spread, you will have more inertia to apply for rotation. Okay, so this lady is extending her body with this rod. But all of us do this without learning science. Let us assume you are walking through a very thin balcony, something like this. You feel like falling. What will be your reaction? Reflex action. Let us assume you are walking like in a thin rock walk. You are falling like. What will be your reflex action?
Hands up.
Hands up, right?
Hands up.
Yeah,
Hands
your
up
hand
and
will, yeah. If you're falling like this, this hand will automatically go like this. If you're falling like this hand will automatically go up. So you're increasing that inertia actually. Because that's a rotational motion. So you're trying to increase your inertia. No?
Yeah.
So it is like when you fall from a 20-story building, whether you know gravity or don't know gravity, also you will die. So your moment of inertia, this is also like that. Okay. So whether you attended science class or not, also when you fall, your hand will go over because that is part of evolution, right?
Yeah.
So that is called moment of inertia. Moment of inertia. Okay. So that is why when you see this skaters and all, when they do skating, when they're last moment when they rotate, they will hold hands up. You'll see. So that much about gravity.
So what is the parachute?
Parachute is based on that the surface area of that balloon. It will have a tendency to go up So that is based on even a normal balloon when you keep, depending on the density, difference in density of the air, whatever is less dense will go up. Okay, so parachute is having huge surface area. It's like a huge balloon you can consider. It wants to go up, but you want to go down. So it is like a fight between gravity between you and Earth, and the tendency or the force on this balloon called parachute to go up. Okay, so when the parachute has enough surface area, it has more force to hold you, or even if it doesn't go up, it will hold you.
So the air is taking you up, the inside air of the parachute.
Yeah, it is less dense. It is less dense. See, that is why you put like balloons, you put hydrogen balloon and all those. It is less dense than the atmospheric air. So whatever is less dense will go up.
Okay. Okay.
That is why smoke goes up. So as I see, Aristotle and all, they thought it is going up because the force is on there, it is to go up. Because always air will go up. That is where they thought is the principle. The principle is because of the density difference. Okay. So what is the time? Can someone tell what is the time?
5 minutes to 6.
Okay. So another 5-10 minutes I'll stop. Okay. Fine. Okay. So this I hope you got it right. Okay. Right.
Yeah.
So you see this, right? So now what happens is, as we told before, the gravity is dependent on the mass of both the objects. Like both the object, in our case, it is us and the earth. So the force with which earth attracts us or we attract earth, both are same. That is what we call as weight. Weight. Okay, so weight is the force between you and earth. Okay, now your mass is how much matter you have. How much matter you have is what is called mass. Okay, now force is actually how much mass you have and how much mass earth has is constant. How much mass earth has is constant, and the distance between you and earth is normally the radius of the earth if you are standing on the earth. If you are standing on top of Everest, radius of earth plus Everest height. If you are standing 100 kilometers above earth, the distance between you and earth is center of the earth, and that is the distance between center of the earth and you. So always gravity is calculated from the center of the mass. So when it is earth, it is center of the earth. Okay. So now that attraction, like between us and the earth, is that what is that force is called weight. But normally sometimes people use these two words, mass and weight, interchangeably, which is not right. Weight is a force. Mass is how much matter you have. Okay. So now what happens is, how do you calculate the force between earth and you?
മനസ്സിലായില്ല മാറ്റർ പറഞ്ഞാ
Matter means like your body,
the volume of
volume into density. Okay, so it is like what is the matter in this book? Okay. What is the matter in this book? Okay, so this book has whatever is the matter, whatever is there inside that is the matter. Okay, so that is its volume into its what we call as density. So that is what we call as mass. It is normally told in kilograms or grams.
Okay.
So what we tell as gram and kilogram is its mass. Okay. So now what happens is, what is the force with which earth is attracting us? That is a different thing. That is a force.
Yep.
Okay. Okay. So now Newton has given an equation to calculate it. Newton has given an equation to calculate it. So hoping projectile, God will pardon, I am writing it here. Um, it is called mass of, let us assume the, we are trying to calculate the force between projectile and Sujit. Let us assume mass of projectile is
100 kg.
You can go. You are an artist. I am a coordinator. She will bamboo me if I call her for another program. So let me keep it as 48 so that she is happy. Okay.
Yeah.
Okay. Okay. So 48 kg. Let's keep his mass. And let us assume what is the Earth's mass. That is this. Okay. And
Yeah.
that divided by, let us assume the distance between she is standing on her house. So that is the radius of Earth. Okay. So let us assume that is R. 6,400 or something is the radius. So whatever is the 600,400, you take it. Square of that. Square of that. Okay. Square of that. Okay. So that is projectile's mass into Earth mass divided by square of radius of Earth. That is distance between her and Earth, which is the radius of the Earth. And so this multiplied by a constant is there. It's a constant called gravitational constant. This is what is the force with which projectile is attracting Earth and Earth is attracting projectile. Okay. So these other values all put together, leaving her 48, all other values put together, we can calculate mass of Earth is constant, radius of Earth is constant. So that we have calculated as one value, which all of you will know. If I tell, you will know what is that value. Any guess? You will all know if I tell the number. So you have heard this figure many times, right? 9.8.
Yeah. 9.
Universal acceleration. That is called universal acceleration. Okay. So that is actually this. So your mass into 9.8 is the force with which you attract Earth or Earth attracts you, or which is your weight.
Okay.
Okay. So that 9.8 is this, which means if you are on Earth surface, 9.8 is the what we call as universal acceleration. Okay. So that is called universal acceleration. What is acceleration? Detail will come. But if you multiply that 9.8, which is actually mass of Earth divided by square of Earth radius into gravitational constant, is what is 9.8. So anybody's mass, if you multiply with 9.8, you will get your weight. So if you want to measure your mass, actually measuring mass is very complicated. You need an X-ray machine to have your figure and have your density, multiply this, that. It's very difficult. So what we will do, we will make something to calculate what is the weight, what is the force between you and Earth. It is very easy. You can stand on a pedestal, use projector, we will make projector stand on it, and we will calculate what is the force she's exerting, which is the force with which Earth attracts. So we will get that 48 into 9.8 figure. We will divide it by 9.8 and the weighing machine will show your mass, 48 kg. It is actually measuring the weight, which is your mass into 9.8, and which divides with the 9.8 and gives you your mass. You get that?
Maths.
No, what I'm saying is mass into 9.8 is your weight.
Mass into 9.8. Okay.
Yeah, whatever is your mass into 9.8 is your weight. Everybody's weight. Everybody's weight if you are standing on Earth's surface. Because if you go to Everest, it will slightly vary because the radius of Earth will increase. If you go to space, this will vary because the distance between you and Earth's center is increased. Right? So we have calculated last part. Why 9.8 is the value? You go home, Google and get what is the mass of the Earth, M, and get what is the radius of the Earth. It will get some 6,400 something, square of that. You get what is the gravitational constant, which is a constant throughout the universe. Get this figure. You will get the value is 9.8. So just multiply. But you are getting it for Earth. Earth mass. It is the attraction between projectile or any body into with the Earth when you are in Earth's surface. Because this radius is what you are taking. If you dig a hole and go below, it is a different story. If you go above, it's a different story. So this 9.8 is only for you in Earth's surface. So 1 kg of your mass, 1 kg of your mass will attract Earth, or Earth will attract that 1 kg with 9.8. If your weight is mass is 48, then your weight by you is 48 into 9.8. If your mass is 100, your weight accepted by you on Earth is 100 into 9.8. You understand?
Calculate mass then. How to calculate the mass?
So how to calculate mass is you have to get your volume. You have to get your volume. Like in your language, you do what is it you call here? That sculptors. What is it? Sculptors. Correct. The sculptors make your yeah.
Armature or bucket? What do you mean? I don't know.
No. If you have to make your body shape sculpture, you will put some stuff and put it right.
Mud, clay.
Mold. Okay. So you take
mold.
your mold.
Okay. Oh, mold. Okay.
Yeah.
That's
You take your mold. So how much water that mold can carry is what is called what is your volume, right?
Okay. Yeah.
So you take a mold of life mold of yourself, and you can see how much water it can carry. That is its volume, right? Okay. But water density is different. Your density is different. So you will get your density. Multiply with your density, you will get your mass. Okay. So your volume. But that is difficult way. Easy way is you calculate the weight. Weight is easy. But when you stand on something, let us assume you are falling from a top of something. So what is the force with which you are falling? Okay. So that force is your mass into this 9.8. Okay. That force with which you fall is mass into 9.8. Okay. So that force with which you fall is mass into 9.8. So when you stand on a pedestal, you will apply that much of force. So you will calculate that value. So you have got your mass into 9.8 value you have got. So how do you get the mass? Divide it by 9.8. Like let us assume projectile is standing on this weighing machine. So weighing machine shows 48 into 9.8. Let us say it is 470. So I got the value of 470. Divide it by 9.8, you get 48. Now Sujit stands, it shows that as 550. So you divide, the machine divides with 9.8. You don't have to do it. The machine internally does it. The weighing machine measures the weight and divides it by 9.8 and shows the value, which is your mass.
Okay.
You understand?
Yeah.
Now this will be different when you go up in there. That is why the space you don't have gravitational force, because space is so high. So this radius of Earth from Earth center to the distance is so very high. So when that denominator value goes up, your force will reduce. So after one point, there is no gravitational attraction of Earth. So this way in the space, there is no gravitational attraction of Earth. But when you go to other planet now, when you go to moon, what will happen? See, when you go to moon, the mass of the moon is much lesser than Earth. Right? Mass of moon is much lesser than Earth. So this 9.8 in moon is a much lower value. It is some 1.6, 1.7 or something. You understand? Okay, so if you are accepting your mass is same, when you go in moon, your mass is the same. Mass doesn't change. It is a matter. You get that?
Stuck. You are stuck in between.
Oh, okay. Is it okay now?
Yeah, yeah.
Yeah, what I'm saying is, let us assume you sit on a chair in Earth, the chair breaks.
Hmm.
The same chair, when you go to moon and sit, the chair may not break. The chair is breaking because when you're sitting on the chair is holding that gravitational attraction between Earth and you. Chair is holding it. That is what the chair does, right? Or a support does that. Now, when you go to moon, if 100 kg is the gravitational attraction in Earth, in moon it is only 16.6. Because moon mass is less. But if you go to sun, it is 2707. Because sun attracts you with a greater force. It is like, yeah, you go and fight with a very small patla guy in your class, you can beat him, and the flow is less. And if you go to a very big guy, you will get massive hit. So the person's mass and this thing is more, you get badly hit. So the mass is more means this thing is more. Understand? This is like for 100 Newton force in the Earth. Like if you are keeping like a concrete structure building in the Earth, you are seeing how much is the gravitational attraction. For that only you are making the structure. When you tell 100 people can sit in this auditorium, that means you are taking 100 people how much a gravitational attraction can be there. So you have to have a strength of the material in such a way that it is much above this. That is how you calculate. But if you are building that in the moon, then it is much lesser. That is the point. See, right? He doesn't have to be this much massive to, in moon. I can also go and lift here like this in moon. You don't have to be this much. I'm telling you. Okay. Okay, thank you very much. Okay. Right?
Yes,
Is it?
go ahead.
No, you go on. You go on. You're a bright student. I'm just.
Pray. Could you do? No, I was just saying that actually we are not aware of these terms, like mass or weight or volume. So yeah, so maybe that's why it's little confusing. Not like that is because we are not aware of this terminology. No? That's why.
Is it okay now?
Huh? We'll have to listen it again, carefully, because yeah, but this thing is like when we make sculpture or even painting, so we always do think about all these things, but yeah, लेकिन ये terms के बारे में उतना consciously सोचा नहीं, so yeah, that's why I feel it's very interesting. Even motion and distance and all these things comes when we think about the painting or even sculpture. So yeah.
Okay, so what is one year here? So walking in Venus and Uranus is much easier, which are much closer to Earth. No, it is nothing to do with Earth warning. Like, it is nothing to do with Earth because Earth's gravitational attraction in Uranus will be very, very thin and minimal. It is to do with those planets' mass of Venus. How much mass is Venus is having? Of course, other masses will impact, but the distance also matters, right?
So is it possible to have a life? Well, life means like there will be something survive if there is no gravitational force in Earth. What will happen?
Gravitational force and survival are two different things, actually.
No, I'm asking, like, everything will go up, right? Like everything will go, right? What will happen? What will happen then?
Yeah, the equilibrium and balance will go. So without the inertia, see, inertia is very, very important. Otherwise, you and me will fly away, na?
Yeah.
Without inertia, we would have just flown away. So inertia, that's what people will tell, but many people use inertia interchangeably with laziness.
Okay.
So this is this thing to tell that actually the whole world is lying because of this inertia. If inertia was not there, people would just fly away.
Yeah.
If everybody works all the time, it would have been a very difficult task to survive. There's some people sleeping to make it happen.
अच्छा, हम लोग जब मैग्नेट पकड़ते हैं, एक दूसरे के ऊपर मैग्नेट पकड़ते हैं, तो एक सर्टेन डिस्टेंस पे आने के बाद उसका वो चिपकता भी नहीं है और वो दूर भी नहीं जाता है, तो उसको क्या बोलते हैं? व्हाट इज इट? वो एक इस पे उसी स्टेज में रहता है.
Yeah, it is holding your telling, hold करके.
हाँ, मतलब वो रिपल, वो मतलब अट्रैक्ट भी नहीं होता है और वो साइड में भी नहीं जाते, तो वो स्टेट को क्या बोलते हैं? वो कांस्टेंट ऐसे ही रहते हैं. हाँ, मतलब एकदम ऐसे.
हाँ, नहीं, वो क्या है ना, वो मैग्नेट्स का क्या आता है, मैग्नेट्स एंड मैग्नेट और ये जो ग्रेविटी में एक फर्क ये है कि मैग्नेट को दो साइड रहते हैं, उसको दो पोल रहते हैं. ओके, तो उसका जो ग्रेविटी में ओनली अट्रैक्टिव है और मैग्नेटिज्म में अट्रैक्शन भी हो सकते हैं, रिपल्शन भी हो सकते हैं, डिपेंडिंग ऑन कौन सा साइड है. लाइक अभी हस्बैंड एंड वाइफ है, रिपल्शन है हमेशा, गर्लफ्रेंड है तो अट्रैक्शन है, ऐसा है. It can go on either this thing. Okay, so now what happens is when you have the attractive position, that attractive force आ गया तो क्या होता है, repulsion का साइड ऑपोजिट आ गया, ऑपोजिट साइड में गया. नेचुरली इसका जो देखो पोल ऑपोजिट नॉर्थ है, इधर साउथ है, इसका इधर साउथ है, इसका नॉर्थ है, तो साउथ और नॉर्थ साथ में रखा, मतलब क्या है, ये साउथ और नॉर्थ अट्रैक्टिव हो गया, बट दूसरा साइड डिस्टेंस में है ना, ज्यादा डिस्टेंस में है. तो इसका नॉर्थ डिस्टेंस में चला गया ना, अदर साइड में चला गया, सो इट विल कंटिन्यू टू बी इन दैट पोजीशन. सो इधर आ गया तो देन इट विल रिपल, बट ये ऐसा नहीं आएगा, नहीं ऐसा है इसका पोजीशन. बट इफ योर पोल मैग्नेट इज लाइक ए छोटा दिस थिंग इधर नॉर्थ और साउथ में, तो ऐसा नहीं होगा. नॉर्मल मैग्नेट ऐसा लेंथी वाला, इसका शेप मैटर्स, इसका पोल कौन सा साइड में, दैट मैटर्स. बट ग्रेविटी में वो रिपल्शन का फंडा नहीं है. Gravity is always attractive. Pura love, 100%. No hate. Okay?
Yeah, I think.
See you next week.
Okay.
आज का ज्ञान करो. Bye.
Thank you, sir. Bye.
Sujit is my guru. So when I ask some blood him on art, now he is thinking that I will settle this current time.
No. I'm just, I asked some question because I only remember that, otherwise I don't remember. I have to ask questions, otherwise I don't remember.
Yeah. You know what Prajakta told was a revelation to me, but I was thinking these are very simple terms like mass, volume, and this thing. But she's also right, because you would have learned so much time years behind. So I will be using it like interchangeably. So that is creating some problem. Okay, we'll see.
Yeah. Thank you.
Bye. Okay, bye.